Hi guys, good morning.
Morning, sir.
So today we'll be doing one important form, right? 1 plus x raised to 1 by x. So have you done this form before?
Sir, no, sir, I don't think so.
There's only one student now, huh? Just you.
Only I'm the sir.
Yeah, that's what I realized. That's all right. Okay, so if k is a positive value, I can write k as e raised to ln k. You know this?
Yes, sir.
E raised to log to the base e k. That's the same thing. Hmm. Alright, this base and this should be the same.
Yes, sir.
For any positive value k, this is true. Instead of e, you can put any positive value here also, except 1. Okay. So this will basically be written as e power ln 1 plus x raised to 1 by x. And you see this 1 by x, right?
Yes, sir. That will
That you
be
bring it outside the ln and becomes 1 by x here. So basically you get limit x tends to 0 e power ln 1 plus x by x, which you can further write it as e power limit x tends to 0 ln 1 plus x by x. Now this part you can apply L'Hopital rule here. Ln 1 plus x, if you differentiate it, you get 1 by 1 plus x. And x, when you differentiate it, you get 1. Okay, limit to 0. You get e power 1 here. That's how you get the value e. Basically, limit x tends to 0, ln 1 plus x, sorry, 1 plus x raised to x will be equal to e. So basically, this is 1 plus x raised to 1 by x will be equal to e. Okay, you guys following? Any doubts here?
no, sir.
Okay. So there's a formula that can be derived from this. So as x tends to a, imagine f of x tends to 1, and while at the same time g of x tends to infinity. And you have a function in this form, f of x raised to g of x. So what do you do in such a case? Even the other one, 1 plus x power 1 by x, we had limit x tends to 0. So as x tends to 0, this is f of x raised to g form only. F is 1 plus x, which is tending to 1 plus 0. And g is 1 by x, which is tending to infinity. So it's almost the same thing only. X tends to a, f of x tends to 1, g of x tends to infinity. Such a case, how do you deal with it?
E power ln f of x power 0.
Exactly. So we'll do that. e power ln f of x power g of x so g is tending to infinity, f of x tends to 1, and ln f of x tends to 0. This is in 0 into infinity form. Okay, we can do one small conversion here. We can write this as e power limit x tends to a. I'll keep g of x as it is. And ln of f of x. F of x I write it as 1 plus f of x minus 1. Okay. So what I'll also do along with this is multiply by f
uh,
of x minus 1
and divide by
and divide by f of x minus 1. Right, what do we get here? F of x is tending towards 1 here. Okay. So we can see f of x minus 1 as a quantity which tends towards 0 as f of x tends to 1. So you have ln of 1 plus x divided by x where x tends to 0. Okay, and we already learned that ln of 1 plus x divided by x comes out to
1.
1 plus x divided by x. Limit x tends to 0. What does this come out to? So
1.
what you can do is apply L'Hopital directly. We already know the formula. It's 1. You can apply L'Hopital directly also. 1 by 1 plus x numerator and 1 is the denominator. And you put x tends to 0 here, you get 1. All right. So this quantity becomes 1 here. So g of x into f of x minus 1. Right. Whenever you get something f of x raised to g of x, which is in that 1 raised to infinity form, you convert it into this directly. E raised to g of x into f of x minus 1. Okay, so this is the technique used. All right, to solve any f of x raised to g of x kind of problems. Function raised to function.
Yes, sir.
Okay, do this.
So E, sir.
Yeah. What is this? This is f of x raised to g of x form. So you write this. e power x into f of x minus 1, which is 1 plus sin x minus 1. You get e power 1 here, limit x tends to pi. This cancels out, cosec x and sin x. You get e power 1, which is e itself. Got that?
Yes, sir.
Look for responding. Hey, the rest of you better start responding.
Yes, sir.
Okay, try this question. So when you put x tends to 2 inside this, what happens? You get 1 raised to infinity form, right?
Even I get E only, sir.
You're getting e. Okay. So this can be written as 1 plus x square minus 4. So what have we done? If you had f of x raised to g of x, limit x tends to a, where f of x tends to 1 and g of x tends to infinity, then what you can write that as e power g of x into f of x minus 1. Okay, limit x tends to a. So otherwise, if you had x tends to a, 1 plus f of x, so this can be easier to remember. Might be, like, at least for me, it is easier to remember. 1 plus f of x raised to g of x. If you have something in this form where f of x tends to 0, okay, the f of x part alone tends to 0 and g of x tends to infinity. All right, you write this as e power limit x tends to a f of x into g of x. Okay, so this is where the indeterminate form is coming, 0 into infinity, f of x into g of x. Right. So here, this is what I converted to 1 plus f of x into g of x. This is tending to 0 and this is tending to infinity. So I'll write this as e power limit x tends to 2 f of x into g of x. F of x is x square minus 4 and g of x is 1 by x square minus 4. And as x tends to 2, you can cancel them out because you're not putting the value 2 there. You're putting a value very close to 2. Then it becomes e power 1, which is e itself. Got this, guys?
Yes, sir.
Yes, sir.
Any doubts here? You want to see it again? All right. Okay, try this problem. Is any answers?
Answer 1.
Hmm?
1 is the answer, sir.
1 now. We'll try. So I'll write this as this x cube minus a later is 1 plus x cube minus 4. Okay. So it becomes 1 plus f of x form. Where f of x tends to 0 and g of x tends to, sorry, it's not x minus 3, it's 1 by x minus 2. Because otherwise what you'll get is 1 raised to 0, which is a determinant formally. 1 by x minus 2, guys. Okay, sorry, this is the question I wanted to ask.
Yes, sir. Okay, sir.
Limit x square minus 3 raised to 1 by x minus 2. The other one was a determinant form, 1 raised to 0, which is nothing but 1 itself.
E power 4, sir.
Yeah. Right? So you get e power f of x into g of x. F of x, you know, is x minus 2 into x plus 2. And you're putting limit x tends to 2. This becomes e power 4 here. Is this question, what do we do? What's the answer you're getting? You write this as 1 plus f of x. And you notice that f of x tends to 0, which is cos x minus 1. And g of x tends to infinity, all right, which is cos square x. So this becomes limit e power, sorry, e power limit x tends to 0, f of x into g of x, which is cos x minus 1 into cos square x, which is nothing but cos square x by sin square x. What do you get from here?
Sir, if the answer is 0,
No, it's not 0. It's not 0.
sir, or is it 1? E power 0. Do you get something in that?
No, it's not e power 0 either. It's not.
So then how do you simplify that, sir? Cos x minus 1.
So you should know that 1 minus cos x can be written as 2 sin square x by 2, right? So
Yes.
that is what I'll use here. So it's the e power limit x tends to 0. So I have cos x minus 1. So that becomes minus 2 sin square x by 2 into cos square x divided by sin square. Okay, this is the same thing, right? Yeah. So you know sin x by x when x tends to 0 is 1. All right. So basically, I'll divide this by x square, and this also I'll divide by x square. But then here, it'll be best to divide by x square by 2. Basically, x by 2 the whole square. So I bring in this 1 by 4 here, which makes this 4. All right. So this bracket becomes 1, this bracket becomes 1. And when I put x into 0, cos square x becomes 1. And then I have e power minus half. Nothing but 1 by root e. This is the answer I get. Are you getting something similar?
Yes, sir.
All of you?
Yes, sir. I got it.
What does it become? E power limit x tends to infinity. This minus 1. So x plus 2 by x plus 3 minus 1. So x and x cancels out. Minus 1 by x plus 3. So this is f of x minus 1 into g of x. What does this become? X tends to infinity here. Sorry. How do you solve this? What's the answer you get here? Guys, what do you get here?
So is it an indeterminate form?
It is an indeterminate form. Infinity by infinity. Yes. Did you understand what I did here to get from step A to step B here? Guys, I'm trying to be as patient as possible. I'm not getting a response from your end. Srivatsan is the only one responding. Can the rest of you even open your mouth, please? Did you understand this step here?
I got it, sir.
Yes,
1
sir.
minus f of x.
Sorry, you get 1 minus?
No, 1 plus f.
So you write this as for 1 plus f of x minus 1. That's the idea. So basically you add 1 to it and you subtract 1 from this. And this part is what comes here. Okay. You subtract 1 part. This into x plus 4. But how do you solve this limit? How do you solve this limit? X tends to infinity minus of x plus 4 divided by x plus 3. How do you solve this? Limit x tends to infinity, 4 by x and 3 by x becomes 0. X and x cancel out because it comes out as a huge positive number. Now, what am I left with? E power minus 1. It is 1 by.
1 by
Please,
e, sir.
please be more responsive, alright? I'm going to repeat this again. Okay, solve this on your own first. This is find the limit quickly. Come on. Are you getting any answer?
So is it after the first step 3x plus 3 e power limit x tends to infinity 3x plus 3 by x plus 3 into x plus 7?
Wait. So what did you do? What did you do in the first step?
I said 1 minus f of x.
Okay. So you added 1 and you subtracted 1 from this. 2x plus 1 by x plus 3 minus 1. So When you subtract 1, when this becomes minus x minus 3. So then it becomes, okay, raised to x plus 7. Limit x tends to infinity. 1 plus x minus 2 divided by x plus 3. The whole raised to x plus 7. And this makes it limit 1 plus something raised to something. So here what do you write this as? This becomes e power limit x tends to infinity x minus 2 by x plus 3 into x plus 7. You know that, okay, you take this limit comes out to 1, this bracket, into infinity. E power infinity form, which is nothing but infinity. Basically, the limit does not exist. All right, that's the idea here. Are you following?
Yes, sir.
Or just need to, yeah.
Yes, sir.
What do you ask?
No, sir. No, sir. It's indeterminate.
Yeah, that's what. It's not really indeterminate. It's actually pretty determinate. You can see that 1 plus f of x raised to g of x, and this x minus 2 divided by x plus 3 tends to 1 when you put x into infinity. Okay, this tends to 1 here. We applied it when it tended to 0. Okay, so what you're getting is a value greater than 1 inside the bracket here, raised to a value tending to infinity. So you know that a value greater than 1 multiplied with itself infinite number of times will be a huge positive value. And that's why you're getting infinity here as the limit. And since you got infinity as a limit, we'll say that limit does not exist. Okay. That's about that question. If you're not following, please ask. Tends to infinity. Okay, this is problem.
Sir,
Yes.
when do we actually use that 1 plus f of x form?
So remember, 1 plus f of x happens when so if you have limit x tends to infinity, 1 plus f of x raised to g of x. No, not x tends to infinity, x tends to a, anything. So when x tends to a, you check the following conditions. Does f of x tend to 0? Does g of x tend to infinity? If all these are followed, then you directly write it as e power f into g. Okay.
Yes, sir.
Now that basically you're converting 1 raised to infinity form into 0 into infinity form. And 0 into infinity form is something which is much easier. That's our logic here. Okay.
Yes, sir. Got it.
All right. So this is. What about this question? Come on, guys. Tell me. What will the answer be? Yes, I've been teaching you for a couple of months now. You guys should be a little faster than me by now. Because I've had enough time to practice. Please keep practicing. All right. Tell me the answer to this quickly. Guys, please do the question first. Come on, what are you getting?
Sir, x square e power x square log 1 plus minus 4x minus 4 by 7x plus 9. That's where I'm stuck, sir.
So that's what, right? So first you have to check this form. When you put x tends to infinity, this comes out to what? This thing inside the bracket comes out to 3 by 7. Hmm. You take the largest infinity outside common and cancel it out. You get 3 by 7 raised to something tending to infinity. You can see that 3 by 7 raised to infinity tends to 0. And this will be the value of the limit. It's as simple as that. Got it?
Oh, okay, okay, sir.
It's already a determinant form. Okay. Now, next question. Guys, ask if you didn't get it, okay? You have 2x plus 3, x minus 5, x tends to infinity.
Sir, I didn't understand the last question. So
The last question was 3x plus 5 by 7x plus 9 raised to x squared. So before you check if it is 1 raised to infinity form, right? But was it 1 raised to infinity form? No, it was 3 by 7 raised to infinity form. This one. Okay, 3 by 7 is a fraction. All right. 3 by 7, you multiply by itself many times, it becomes lesser and lesser till it goes closer to 0 if you multiply it with itself enough number of times. Okay, infinite number of times. So 3 by 7 raised to infinity is tending towards 0. Did you understand this? It's not a 1 raised to infinity case. 1 raised to infinity case was the indeterminate case. When I put limit x tends to 0, what do? I take x common in the numerator out. So I get x into 3 plus 5 by x. Denominator also I take x common. X into 7 plus 9 by x. X and x cancel out because limit x tends to infinity. And 5 by x and 9 by x become 0 because limit is extending to infinity. I'm left with 3 by 7 here in the base here. Okay. So it's 3 by 7 raised to infinity form, which is basically nothing but 0. Are you getting this or should I give another explanation?
Yes, sir.
I'm sorry, I got it. Thank you.
Okay. So, yeah, now look at this question. How about this one? What is the thing inside the bracket 10 to? Exactly. Inside the bracket, the value tends to 2. And on top, the exponent tends to
Infinity.
pure infinity. Check, check, check. Not exactly infinity. That's right.
Minus infinity.
Exactly. You have something tending to 2 here and something tending to minus infinity. You have something tending to 2 power minus infinity. Basically, you have something tending to 0 here. Directly, that is the limit. It's not indeterminate. That was the catch in this. First, always check if it's indeterminate and then start solving. Okay, how do you solve this first? Sine of x square minus 9 divided by x minus 3. Hmm. What form do you see here? Is what form do you see here?
Sin x by x.
Hmm?
So sin x by x.
Not sine x by x, but you can see 0 by 0 form, right? When you put x tends to 3. Okay. So you have to remember that you have to bring sine x by x here. This is not sine x by x. This is sine x square minus 9 divided by x minus 3. The denominator should be x square minus 9 for it to be a sine, this thing, sine x by x form. Hmm. All right. So what you're basically doing is dividing by x square minus 9 and multiplying by x square minus 9. Okay. Basically, this part becomes sin x by x and turns out to be 1. And I'm left with this part here. All right. So when you get a question here, you can directly replace sine of x square minus 9 by x square minus 9. I understand the technique in which it's done.
Yes, sir.
All
Yes,
right.
sir.
This becomes x plus 3. That's it. So you just put x plus 3 in your mind here and you get answer as 6. Okay. So another one. Okay. Yeah, see here. Come on. Yeah, denominator is coming out to 0. Numerator is coming out to sine of sine pi. And what is sine pi? That is 0 itself. Okay. Right. So you're getting a 0 by 0 form. Correct. It's indeterminate. So you'll have to do something here. What does that be? What do you do? You in your mind you'll multiply and divide by sine x. You need sine x by x. So here the x part, the angle part is sine x itself. So divide and multiply by sine x. You can see this is sine of 0 by 0 form. Okay. You can see 0 by 0 form happening here. So this becomes 1. And I'm left with the sine x by x square minus pi square. And I'll call t as x minus pi. What will happen here? Limit x tends to pi becomes limit t tends to 0. And sine x becomes sine pi plus t. X square minus pi square can be written as x minus pi, which is t, into x plus pi. X plus pi means t plus 2 pi. Okay. So sine pi plus t is nothing but minus sine t divided by t into t plus 2 pi. Limit t tends to 0. This becomes 1 sine t by t. And then I get minus 1 by 2 pi as my final answer. Let's check and ask doubts.
Sir, is the answer pi, sir?
The answer pi, we'll find out. Okay. So the idea here is sine pi by x. So when x tends to infinity, what does pi by x tend to? It tends to 0.
0, sir.
So I'm looking for this divided by this only. Okay. So basically divide by pi by x and multiply by pi by x. So in my, basically when I see the question, I'll just multiply by pi by x instead of sine pi by x. I'll replace that. Okay, so it's x into pi by x, which becomes pi. And pi is your answer here. Absolutely. Okay, that's the right answer. Now, okay, what about this one? Remember, cos x can be written as 1 minus x squared by 2 factorial plus x cubed by, sorry, plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on. So when I write it in this form, this is what gets subtracted. Okay. And I'm left with x power 4 by 4 factorial minus of x power 4 by 4 factorial plus x power 6 by 6 factorial and so on divided by x power 4. So when I put x into 0, I'll get nothing but minus 1 by 4 as my
Sir,
answer.
how is cos x equal to 1 minus x square by 2 factorial?
Okay, for that, the expansion you should know. There is a way of doing this. One second. Okay, so if you did complex numbers last year, all right, you can say that cos x plus I sin x is nothing but e power ix. Cos theta plus I sin theta is nothing but e power I theta. Okay, this is something you should know first. All right. Now, e power x can be written as 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial and so on. Guys, are you with me on the same page till here?
Yes, sir.
Okay. Now, I will write e power ix as 1 plus ix by 1 factorial I square x square, which is, what is I square here? Minus 1. Okay, I is root of minus 1, I square becomes minus 1. And then plus I cube x cube. I cube is nothing but minus I. So x cube to 3 factorial and so on. Okay. Now, e power ix is nothing but cos x plus I sin x. That's what we add here. All right. This, I'll take the real part separately. 1 minus x square by 2 factorial. The next term will be plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on. Okay. Then I'll take the I terms common, the imaginary terms. Plus I into x by 1 factorial minus x cubed by 3 factorial and so on. Are you getting this, guys?
Yes, sir.
Yes,
So
sir.
you equate the real part separately and the imaginary part separately. So this becomes cos x in the first bracket and this becomes sin x in the second bracket. Getting this? Are you following?
Yes, sir.
Yes, sir. Yes, sir.
All right. Okay, write some expansions. They're useful for you. Okay, this is as x tends to 0, this becomes true. All right. E power x is this. E power minus x will be replace x with minus x everywhere. As simple as that. Okay. So sin x and cos x you got to know. Now write for tan x. Tan x will be x plus x cubed by 3 plus 2 by 15 x power 5 and so on. Okay, just note this down. Okay, use this logic to find this answer.
Sir,
Since
for
we,
tan x,
yeah,
after 2x power 5 by 15, what will be the next term?
just learn only this much. They won't ask anything more than that. They generally don't even ask tan x. But this is only to solve some tough questions. And plus, remember tan x, you'll have to remember it. You have to by heart it.
Okay.
Okay. Like, I wish I could tell you a formula, a way to remember it, but it's best to by heart it. Yeah. Sin x into cos x is to minus 1. That's all they solve it. But that's too much of a big. Usually. What is sin x? And tan x is, sorry, this is x minus 6 plus x cubed by 3 plus 2 by 15 plus 5 and so on. The whole thing divided by x cubed. So x and minus x cancels out. Minus x cube and minus x cube is there. Minus 2 cubed by 3 factorial. So this becomes plus 2 by 6 and this becomes minus 1 by 6. It becomes plus 1 by 6. And x cube by 6 plus 1 by 3. Okay, this becomes 1 by 2. So it becomes minus x cube by 2 in the denominator plus x power 5 by something into k divided by x cube. The limit x tends to 0 is what is there here. So the remaining terms here cancel out to become 0, x power 5 onwards. And here I get minus 1 by 2 remaining. And that will be my answer.
Sir, I did it like you take it as two separate fractions, sin x by x cube and tan x by x cube. And then if you apply the limit for one, you will get sin x by x as 1. So 1 by x square will remain. And then minus tan x also you will get.
But 1 by x square comes to what? That is some infinity value, right?
Yes, sir.
Same goes for tan x also. You'll get some other infinity. You're basically converting it to infinity minus infinity form, which is tougher than the form that we already have here. Sin x minus sin x by x cube.
Oh, okay,
What we
sir.
have here is 0 minus 0 by 0. Basically, we got a 0 by 0 form. That is what we generally convert everything to.
Okay, okay, sir.
Okay. So it's like much more convenient if we keep it in 0 by 0 form itself than converting to infinity minus infinity. The problem with
Yes,
infinity minus infinity is you can't do anything after that other than rationalize it.
yes, sir.
That is one issue with it. Yeah, that's the only issue with it. Did you get how we got minus 1 by 2?
Yes, sir.
Okay. Okay. Limit x tends to 0 plus x raised to x. This was that. There's some 0 raised to 0 form. Write this as e power x ln x, right? Okay, what are you guys trying?
Sir, does the answer become 1?
Yeah. The answer should become 1. Yes. What did you do?
Sir, after that you take.
X. So substitute 0 in place of x and we get e power
No,
0.
but 0 is there. Ln of x is what? Ln of 0. Ln of 0 is minus infinity. Not ln of 0, ln of a small positive quantity. The x tends to 0 plus. So that is
Sir,
0 into
1
infinity.
plus.
This is determinant.
1 plus x minus 1 by x minus 1 into x minus 1.
1 plus
E power x into 1 plus x minus 1 by x minus 1 into x minus 1. Something like that.
1 plus x minus 1.
By x minus 1 whole divided by x minus 1 into x minus 1. Oh, sorry, there's a log, sir, before x.
Okay. All right.
Then the
The
log
problem
part gets.
is should tend to 0, right? For me to cancel this out, I need x minus 1 tending to 0. That's not the case. Right, so don't worry. What you can do here is e power x into ln n. So you can write that as ln x divided by 1 by x. Okay, limit x tends to 0 plus. Now I'll simply differentiate both the sides, like numerator and denominator. Lapita rule. 1 by x minus 1 by x square. So you'll get e power minus x limit x tends to 0. So which is e power 0, which further becomes 1. Is any doubts here?
No, sir.
No, sir.
Okay, so this is it for the chapter limits. All right. Now, guys, please start responding. Okay, it's very difficult to take class like when people don't respond. All right. Like there are 2 of you who respond all the time, but the remaining, both of you, there aren't many people here, right? You'll get individual attention here. So please use it. Okay. Please start asking better doubts. And yeah, make this class productive. So I'm ending the class right now. Okay. I don't think I can teach you anything else right now. Please start responding from next class onwards, please. All right. Am I clear?
Okay, sir. Sorry.
Yes, sir.
Yes, sir.
All right. That's it for class today. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.